So today's lesson is on solving absolute value inequalities, and we are going to use the definition of absolute value to rewrite all of our absolute values as inequalities in the form of a compound inequality. To review from last year, if you have an inequality with a less than symbol, it typically ended up becoming an and statement where it ended up being between 2 points. And if you had a greater symbol, greater, it ended up becoming a or statement respectively. So the reason for this is because of our two cases and the definition of absolute value graphs. So there are two examples that are given here, but I'm going to go ahead and start with the exercises down here, example 1, and showing you the work that is necessary to really understand what is going on here with the absolute value. So for number 1, I'm going to recopy this on a separate sheet of paper if you folks would like to do the same and follow along, taking notes. The definition of absolute value is that you have a number inside, whether it's positive or negative, we're taking its absolute value, its distance from 0. So if the inside amount, is equivalent to a positive 7, the absolute value of that would be positive 7 and it's less than 8. If the absolute value of the result ends up becoming a 6, then same thing. If it's a negative 6 or a negative 7, the absolute value of that is positive 7, and it also makes it true. So what I like to do is have students set up two cases. The positive case is whenever you have this 3x plus 4, this expression for the inside number has to be less than 8, and that could be any number like 7, 6, 5, 4, 3, 2, going all the way down. And so this number right here, if we go ahead and solve the two-step equation, we would get 3x is less than 4, therefore x is less than 4/3. So as long as x is any number lower than 4/3, we are making that statement true. However, this could also be a negative number due to the definition. So if you think about the negative case, this 3x plus 4 could be a negative number. So I'm going to actually throw it in parentheses with a negative sign out front, and I'm going to write that number could also then be less than 8. If we go ahead and distribute our negative, it's a little bit more work. We can add our 4 to both sides. And we go ahead and divide both sides by -3. Now something happens here. When we divide by a negative, it's the same as reversing that inequality symbol to keep the statement true. So we need all of the values to be greater than -4 and at the same time lower than 4/3. That would be shaded as an open circle on -4, an open circle at 4/3, which is like 1 1/3, and we need to be a less than is an and statement. We need both of these to be true at the same time. So we have to be higher than -4 and at the same time lower than 4/3. Now you can actually write this as a between statement between -4 and 4/3. X has to be between, or you can leave it as two separate with the and in between. That works as well. So let's go ahead and try it again on example 2. Example 2, I have the absolute value of 4k plus 1 is greater than 27. Before I break up my two cases, I really want to try to isolate that absolute value, the same that we did whenever we solved absolute value equations. So we're going to try to isolate this 4k by go ahead and subtracting 1 from both sides, and then we can break up two bars, two cases. So case number 1, the positive case, 4k is greater than 26. It's a great Tor symbol. So our second case, our negative case, the negative of 4k has to be greater than 26. So in the positive case, we get k is greater than 26/4, which of course simplifies, they're both even numbers, to 13/2. Or here, I don't need to distribute the negative because the 4k is a monomial. So this is just going to be a negative 4k when you multiply -1 times 4 times k. And then we can go ahead and divide both sides by -4. Now I'm showing this step because I really want you to see that when you divide by negative, you have to reverse that inequality symbol, and 26/4 does simplify down to -13/2. So if we go ahead and graph this, remember 13/2, 12 goes in, or 12 divided by 2 is 6, so this would be like 6.5. So this is 7 right here, so 6.5. It's going to be an open circle right here. I need to be greater than 6.5, or I need to be lower than -6.5. So I'm going to do an open circle there as well and shade below. So this one here, because of the inequality symbol, this one ends up being an OR statement. All right, 2 more examples. All right, 2 more examples, and then we will, I'll give you a chance to try it on your own, and you can check your answers. So again, for number 3, we're going to do the absolute value of c divided by 2 minus 3 is less than or equal to 5. By the definition of absolute value, we're going to have 2 cases. So case number 1, just write your expression as is. C over 2 minus 3 is less than or equal to 5. Look at the symbol. It's a less than, which is an and statement. Our second case, our negative case, will be the negative of c over 2 minus 3 is less than or equal to 5. All right, so for case 1, we're a 2-stepper. We're going to go ahead and add 3 to both sides. And then we're going to multiply both sides by 2. So c is less than or equal to 16. For our negative case, I'm going to distribute the negative, subtract 3 from both sides, and then I'm going to multiply both sides by -2. 2 will get rid of the fraction, the negative will get rid of this negative sign here, but that will reverse the symbol to be c is greater or equal to -4. So when we go ahead and graph this, this will be a closed dot on -4 because it can equal, and it will be a closed dot on 16. We need to be lower than 16 and at the same time higher than -4, which will be all the values in between. All right, last one, and then I'll let you try a few. Number 4, we have the absolute value of a plus 9 is greater or equal to 30. In this case here, we're going to go ahead and break it up. It's already isolated. So positive case, gray Tor symbol, so it will be an OR. The negative case. Again, I'm going by the definition of absolute value. After a while, you notice a pattern that occurs, and some people like to take a shortcut and just break it up into an and or an or based off of that. However, I just find that going through it, definition, distributing, and doing all the things that you're really good at really helps you to understand it a little bit better. Oops. A little bit off there. Sorry about that. So I distributed the negative on the negative case, added 9 to both sides, and divide by -1 or multiply by -1, however you want to think about it. we are going to be less than or equal to negative 39. So here's negative 40. We're going to be just really close to negative 40, less than that. Or 21, so just a little bit higher than 20, closed dot. And we'll be shaded higher than that. Alright, so I'm going to go ahead and let you try the rest of them, and you can check your answers. So if you want to pause the video and then turn it back on when you're ready to check your answers. Alright, so if you did number 5 correctly and broke it up into its two cases, you should have got f is greater than 10 or f is less than 1. Number 6, you should have gotten that w is between negative 6 and 26 fifths. Number 7, you should have got k is between 4 and 6. For number 8, you should have gotten x is less than negative 6 or x is greater than 26. For number 9, you should have had b is between negative 3/2 and 7. And finally, for number 10, you should have gotten that w was lower than 80 thirds or w is greater than 40. If you think that you got the lesson, great. We will be doing the assignment, the Solving Absolute Value Inequalities worksheet in class tomorrow, and you can ask lots of questions then. Thanks for listening.